Today we're going to talk about Lee-Kessler's compressibility factor Z. So in chemistry class, you talk about the ideal gas law a lot, PV equals nRT. What the teacher does not tell you is that ideal gas has a Z factor of 1. Now, this Z factor is incorporated into the ideal gas law equation, PV equals nRTZ. So since ideal gas has a Z factor of 1, they normally neglect it from the equation. So when they're teaching this equation to you in class, it's PV equals nRT. Now, another important fact to know is what critical temperature and critical pressure is. Critical pressure and critical temperature is when gases become more difficult to liquefy as the temperature increases. The critical temperature and critical pressure of the substance is the temperature at and above which vapor of the substance cannot be liquefied, no matter how much the pressure is applied. So that's the definition of what critical temperature is. So now that you know what the definition of critical temperature and critical pressure are, the way to look, every molecule has a critical temperature and a critical pressure. And in the back of a chemical engineering book or a chemical engineering manual, you would find these critical temperatures and critical pressures. If you look at the back of this engineering book, here you would see the critical temperatures and the critical pressures. There's critical temperatures and critical pressures of all these molecules. So let's pick one molecule, for example. If we look at acetone, the critical temperature of acetone is 508.1, and the critical pressure of acetone is 47.01. So now that you know the idea behind critical temperature and critical pressure, now you can find the critical temperature and critical pressure of any molecule. So now you have to find the reduced temperature and reduced pressure. There are two special equations to find the reduced temperature and reduced pressure. These values that you get are very special because these reduced properties help you to find your Z value on a graph called the Lee-Kessler's chart. That's the significance of the reduced values, to find to find the Z point. So from your original problem that you're given, your chemical engineering problem, you would normally be given a temperature and a pressure. So you plug in your pressure over your critical pressure and your temperature over your critical temperature, and you get your reduced temperature and your reduced pressure. Once you find these, then you can finally look at your Lee-Kessler's chart. This Lee-Kessler's chart is pretty much a graph which helps you to find your Z factor. So you go to the front of your Lee-Kessler's chart and you look up the values. So you see there's a PR and there's a TR value. So these are the TR values and these are the PR values. So you line the PR value with the TR value and you get your Z value, which is on the y-axis. So this is how you find the Z factor on a Lee-Kessler's chart. Thank you.